presentation part. So this is a general presentation available on the Google. You can search it out. You can get this. So basics related to transient analysis. Why we need transient analysis and what actually the requirement is. So we have solved until now what we have seen. We have solved steady state thermal calculations where we applied temperature at one location, and we found out that like how my temperature will progress, so or maybe reduce as per I am having like boundary conditions. Again, we have calculated thermal stresses, like because of temperature difference, how my body is behaving and what stresses and deformations are coming into my body. So those portions we have seen. But now, if you ask me, maybe if I am hitting my body from one end, and maybe after some time, maybe after 5 seconds, after 5 hours, or after 10 hours, I need to see like what is the status of my body. So I heated my body at one end, and the outer end you predicted by using yesterday's or steady state calculations. So it was giving me like maybe if I'm applying 200 degrees Celsius at one end, at other end you might get like 100 degrees Celsius. But is that the case after some time, maybe after 5 seconds, 10 seconds, or after an hour? So will that be the case? So for that, actually, we need such transient calculations. So maybe here also you have some examples. Maybe how long does it take for a cup of coffee to cool down to room temperature? Maybe if I just take a hot cup of coffee and just put it into the ambient air, so how much time it will take to cool it down? So to predict this, we need such transient calculations, right? So again, these transient calculations are useful in heat treatment problems, electronic problems, even in case of like nozzles where I'm having temperature, in engine blocks and in pressure vessels. So everywhere, basically, this methodology of transient analysis is applicable. So where basic need is to find out the behavior or the results after some duration of time. Fine. Or maybe a reverse case might be possible. Like you need to find out how much time it will take to get the desired results. So for that, you need such transient calculations. Same thing, you need some inputs, so you will have this kind of outputs. Same thing again over here, we have the governing equation. I think this is for conduction, so rate of heat conduction, rate of storage inside the volume. So this equation basically will be used in the backend. This term has basically, which is nothing but my transient term, so which deal basically with, so you can say dou t by dou t. So it deals with my time. So depending upon my time, so this considers whatever temperature I am here. From this graph, you can see temperature is around 120 degrees Celsius. But as I progress in time, so starting from 10, 20, 30, so after like 1 hour, or maybe after 60 seconds, sorry, after 1 minute, I'll say, so what is my temperature? So yeah, so that is the case where we need this transient calculations. uh, so here same thing is mentioned. Transient thermal analysis involves loads that are function of time basically. So that's what we saw here. Loads, these are loads, those are now function of my time. The first step is applying, okay, that's fine, initial temperature do not matter. So what we were doing in steady state analysis, or like our yesterday's calculations, so we simply define a final load, like, or maybe a final temperature. In case of yesterday's piston, I remember we used like 2000 degrees Celsius in a single step, so from 0 to 2000 degrees Celsius. But in reality, is that the case? So in reality, like, my temperature may first reach 100, then it may reach 200, 300, and likewise it will reach to 2000. So after following some steps, so that we can simulate over here. And here they have mentioned one example. So maybe why actually initial temperature is important, because when you leave like ice water and hot tea, maybe in ambient air or maybe in the sunlight for 5 minutes, so will the their final temperature similar or will they be different? So this is really a need. Here we need to know what will be their temperatures after the duration of 5 minutes. So that's why we need such transient calculations. So these are very I'll say very easy examples just to understand it. But in reality you will need such calculations in case of maybe engine blocks. If my engine is running for this much duration of time, so after this much time, what really the state of my engine is, so that you can calculate basically by using these calculations. Again, thermal capacitance. So this terminology is very important. You can correlate this terminology basically. So what here they have done, so they simply made this in the form of the same one we have for structural calculations. So only it is replaced with time instead of deflection. And this t, actually this says it is dependent on my time factor, so heat rate vector. So vector means it is changing as regards to my time. Fine. And this is my conductivity matrix. So we can have the structural analogy. Yeah, it is explained over here also. A body with larger thermal capacitance will take more time to heat compared to body having smaller capacitance. The same thing, just consider maybe just consider maybe solid ball and to just move those balls. So where you will need more energy, so you will need more energy obviously for a bigger diameter ball. So same ways, capacitance will take more time to hit and body having smaller capacitance, basically this term, the first term. So here it will take the same thing. Maybe I can simply explain you over here. So only change is, here I'm having deflection, here I'm having temperature. So this equation, you know it very well, the equation of motion. We already solved many problems by using such equation. So what this terminology says me, this is nothing but inertia, and m indicates mass of my body. So larger is the mass, then larger is my inertia, and larger is my resistance, basically resistance to motion. So same thing, if my this c value, this capacitance value is more, then larger is my resistance, right? So you can simply differentiate between these two equations. The right side one, it we solved for our structural calculations, and now this one we will solve for our thermal cases. So I guess yes, this is related to electrical, so we are not interested in it. So any question you have, because this is something new. So if you have any question in this theory, so you can ask me. If not, then we will move to our calculation part. Do we have any question? So you understood why we need basically, or what is transient analysis and why we need the transient analysis. Have you understood? Or do we have any question? Okay, fine. So we will just move to the calculation part. Let's just check what we have for today. Okay. So problem statement one says I need to calculate the piston. I think the same one which we calculated yesterday. But yesterday we just applied this temperature in a single step. But instead of that, I need to now apply the temperature uh, in 10 steps. So basically, I'll say uh, for 10 seconds. So if I just say this time is 0 2 and unit should be like in seconds, then I should apply this 2000 for 10 seconds, right? So that this should be my input. So here you can compare like the yesterday what we did, we simply applied 2000. We haven't considered like any stepping over there. So here we have a time stepping like starting from 0, 100, 500, 800, and it reaches at the end 2000. So if my requirement is maybe at this time, so at the time of maybe 7 seconds, at the end of 7 seconds, how my means this piston is behaving. So that I can come to know in this transient calculations, but it was not possible in our earlier calculations or yesterday's calculations on like steady state thermal assessments. Fine. So additionally, we need to know the we have on the similar fundamentals we have transient structural calculations. So if you come to know regarding this transient thermal, then it will be easier to you. So you can by yourself try this transient structural cases. So I'll simply check the engineering data. So just check over here in transient. So same, I have thermal properties defined. Just go on to the project again. So as my structural steel default material itself, and that's only I need to use. So there is no new material again. So I'll simply go with the same material. Now geometry. Mm, I guess my first is the piston. Just say generate. Okay. So yesterday we did some geometry cleanup work. So yesterday I shown you like how we can merge these phases. So there is one more option actually available here in Design Modeler. Maybe I'll show you that today. In tools, in said like repair. Maybe if you have some such edges or maybe some small holes, if they are available, use such repair command. So here, what you need to repair? So repair hard edges, repair only edges, or repair sharp angles, holes, slivers, spikes, maybe faces, or maybe bodies. So here I just want, I'll say repair my body because I'm having some edges in my body. So let's see how it goes. Maybe here bodies need to repair. So bodies to search. currently it is selected as visible body, so this is body which is visible. Or else I can just select selected bodies and then just click on that and say apply. If in case if I'm having more than one body available with, I can simply go with visible bodies as I'm having only one body. Now I have to set like minimum and maximum limits. So basically it is a unit of volume. So from 0 to 400 millimeter cube. So in that volume, if you find any error, or maybe if you think there is a need of repair, so just find out it. And fault limit means total 50 number of faults it can find in this range, minimum and maximum range. I can increase it to 100 also. If my model is too much dirty, then I can simply make the fault limit to 100. If only two, maybe for example, if only I know two faults are available in this body, so even if I set it to 100, it will only search two, because there are only two faults, so no more than that. So it don't have anything afterwards. So it will find at the end only two faults. So here limit detection, it is set to manual, right? So or you can just go to selection and select it manually, like that also you can do. Now here find faults, now it is set as no. Click on and say yes, it will find automatically. So got it. So this tab has pop up, so it is saying no faults found. So when I simply set it to S, then this tab has been uh, and it is saying that there is no any fault. So maybe now I need to change my repair method. So it is saying my body is good. So again I will go to tools, I will go to repair, and I will say repair maybe hard edges. So maybe in case of any blowholes or something, like if I'm dealing with casting, in that case might be option will solve our purpose. But here might be this one will solve our purpose. So visible bodies, again same thing, process edge joints, no. So edge joints will be like at this edges, so I do not have that over here. And here find faults, now I'll simply say S. Let's see what I get. So here also it is saying there are no any faults. So let's try. Okay, so I simply behaves here. Yes, yeah. Now you can see what faults it has found out. So this is the sleeper one. It has detected automatically. So it is showing for this phase. Maybe I'll go to the second one now. So this is second one. So second one is for this phase. Let's try by generating it. What we get. Oh no, this is doing something wrong for me. So it is basically deleting the thickness over here, and it is creating some small shaped body. So this is also not useful in this case. Maybe we'll check for maybe any other option. Let's see how to repair edges. Maybe repair face. It will work. Let's see. Visible bodies, and this is the limit, like minimum and maximum. Yeah. So this option fits for me now. So what it will do, uh, it will find out the face. So as per this is ANSYS, so this face is having some error and it needs a repair. So what repair it needs? So here basically it has set to automatic. So it will decide in between face merge or edge merge or something like that if you it is set to automatic. And if you just want to have face merge option, So you want like a system should not decide by itself and do automatic repair work. You can set it manually also. Instead of automatic, you can simply set maybe face merge, right? But for time being, I'll set the same thing and say generate. So afterwards, let's see how my model will look like. Okay. So can you see? So I have so here I had basically some edges, but they are still there. But you can see this portion. So this portion is now without any edge. All the edges has been gone. Got my point? So maybe I'll simply suppress this to let you know again. So can you see these edges over here? So here I have like multiple faces. So if you think those are not required in your calculations and they are taking like unnecessary nodes and elements and they are increasing your solving time, so you can do such things. So yesterday we have seen like how manually you can select and just merge the faces. Today with this repair tool, so it will be faster if you have like bigger model or bigger assembly with such lot of errors. Fine. For time being, I will keep it as it is. This was only for your learning purpose, just to for to you to know that such commands are available. So I'll enter now into the mechanical. Just double click on that or right click and say edit. I will be into the mechanical window then. Okay, who are one like those are trying along with me, so trying on their system. So maybe that if the number is more, then I'll be much slower then. Uh, can you simply just put a message like you are trying or you are solving along with me, uh, so that I can come to know that you are also trying from your end. So same problem you basically take and you just solve along with me. Uh, who are those like those are having ANSYS installed and they are trying now with me? Okay, I got one. Now I just check the material assigned. So by default it has assigned structural steel. Then do we have anything regarding mesh? Yes. So we need to have it size to 3 mm globally. So I add 3. Let's just right click and say generate mesh. Okay. So I have meshed it with the 3 mm size, element size. Now coming into the transient. So can you see the difference over here? So here basically this additional tab, it is saying me like initial temperature and so maybe I'll go back and just check. So I need to have maybe 3, 4, 5, 6, 7, 8, 9, 9 load steps starting from 0. So one is missing from 0, 2, 3, 4, 5 is also missing, 6, 7, 8, 9, 10. Fine. So two digits are missing from 0 to 10 means two are missing from 11. So we need to have 9 load steps. So what I will do in number of steps, I will simply enter 9. And you see over here, so it has generated for me such 9 load steps. fine. So first starting time and it is like 1 to 9. It is showing like that. Now we'll simply move to the uh, boundary conditions. Let's see what boundary conditions we have. So first is the temperature. So what I'll do, I'll just click on the thermodynamics inside and say temperature. So where? On the top face. Fine. Now maybe I will just drag it and maybe we will see it side by side. Then it will be easier for us to type on. Okay, I guess it's visible to everybody. So this is not a smaller one. Fine. So what I will do, so at 0, I have temperature of 0. Then for 2, I have temperature of 100. Getting it? Then for 3, I have a temperature of 500. So maybe what I will do, I'll put 100. Let it be. Now we will just check for 4. I will enter 800. For 6, I have 1300. For 7, I have 1500. For 8 and for 9, I have 1900. I will define one more load step. Let's check. So for 10, it should be 2000. Okay. So I just checked. It is not possible to just neglect it over here. So we have one more option to do this one. So as we do not have my first load step, so what I will do, maybe I will simply deactivate from here. But for time being, I'll say let's go ahead with this, and that deactivation we will do afterwards. Maybe we will solve this run first, and then we will simply say maybe right click, and I don't want this first load step. So there is one option: activate and deactivate this load step. So either you can activate or deactivate by using this method. So if it is not required, maybe 1 and 5, these two load steps are not required. So you can simply deactivate those. Okay, first of all, we will solve it for the for this. Oh, I need to select all the faces. So can anybody tell me how I can select those faces? How I can select too many number of faces? Because to select all the faces, I will need to like do such things. How I can select those faces?
So from raising a square from left top to right bottom, sir.
Yes. Good, good. Very nice. So instead of single select, I need to go to the box select command first. So I just go to the box select and I'll select like this. So here, by both way I can select because I eventually want everything from this body. So what is the difference between right to left and left to right is if you are dragging from left to right, so then whatever inside your box will only be selected, and if you are dragging like from right to left, so even if you have a smaller portion of body inside your box, but your all other portion will get selected. So that's only the difference between both selection. But now yes, this is a good answer. So with by single selection, I will simply deselect this, and I'll add it over here. So all 49 phases has been selected for my convection. Okay, so here I have to apply film coefficient as 0.2. So maybe can you see again over here? Okay, convection coefficient zero point 0.2, and we have applied the temperature with the 10 load steps. Fine. So now, so here you can get, so this is also additional. So this was not present over there in the steady state thermal calculations. So here what it says, temperature on global maximum and temperature and global minimum. So max and min, it is already showing for you. So let's just solve it and just see how it goes. Now actually, as we have defined 10 number of steps, that's why whatever time it took for one case yesterday, now it will take little bit more time, because now we are solving more number of steps. So let's check the, from here also you can check the overall progress. Let's see. So it has up to around 60-70%, 60% I guess. So when it reaches to this one, you can say it is complete, and here in bottom you can see what basically my solver is doing. Now it's preparing the mathematical model for some of the load step. Now it is writing results for that step. So fine, so this is complete. So here you can see so how my temperature behavior is, like global maximum one, so starting from 1 to 10 seconds. So can you see, so starting from 23, so we started from 0, right? So at 1 I'm having around 23 degrees Celsius, so it just goes on to like this. So even the same thing for global minimum, so likewise. Okay, now what results I need to add temperature. My temperature profile will be visible. Just I'll say right click and say evaluate. Okay, so now by default here I'm having display time as a last. So the important thing I told you regarding transient calculations is that I can extract results wherever I want. So if I want my calculation at the end of this fifth load step, maybe at the end of somewhere here after 1300 degrees Celsius. So I can do that. So I can simply go over here, maybe click. So I do not have 6. Yeah, here I am having 6. Or I have one more option. Simply go into that table, click over here. So this is my 97 number row. So click on here and just right click and say retrieve these results. So you can see this has automatically changed to 6. Earlier it was saying last, but now it has changed to 6. And I am seeing results for that 1300. Got it? So now maybe we will check for any other, maybe for 7. So just click on this 110. So that's then my total row will be selected. Right click on any selected cell and then just say retry. So can you see here? So here it has automatically changed to 7. Even here this line has changed from 6 to 7. So same thing what I did in table, I can do it over here in graph also. So I just click on this 5. So my line will come to 5. I right click and say retry. So automatically my selection will move to this 5, and here also my display time will change, and here results I will get at the end of 5 seconds. Got it? So this is basically the difference between my steady state calculation and transient calculation. So I just want to check heat flux. So just go and say maybe directional heat flux. So I'll select Z axis and say evaluate. So by default, I will get my heat flux at last time, whatever it is. So in my case, it's 10. So at this time step, I'm getting results. You can see the line, it is present over here. right? So you can just click anywhere, so any results you want, and you can have just right click and say retry. You can have that those results. Fine. Now I have to look for equivalent stress and total deformation. So can anybody tell me now? So yesterday we did same thing in steady state calculations. How I can calculate these results here in transient analysis? Can you tell me? Can anybody tell me how I can get those results?
Right click on solve and go to insert and add a equivalent stress and deformation.
No, no, no. If I right click, I do not have any option about stresses over here. I told you yesterday, like where I have stresses and where I have results. If I right click over here, I cannot see any stress or deformation. Hmm? So maybe we are missing something. So we missed some step, or what it is, or how can we get that the equivalent stresses? If I just click on solution, so everything under solution will pop up here in this row. How I can
I
do?
think we need a fixed supports.
Okay, but where should I add fixed supports then? So here, where should I add fixed support? So if I right click over here and just say insert, then even that fixed support option is not visible for me here. So only temperature, convection, radiation, heat flux. So I do not have even the option of fixed support present here. How can I add then fixed support? Hmm? Anybody else can try and say me like how can I mm, in custom system? Okay, this is also good answer, but not 100% correct,
Sir, please test,
because
sir.
yes, yes. So you are correct, but in custom system, actually now I have solved my thermal calculations. I just need my equivalent stresses. So if I just go and say thermal stress, maybe in from custom system, I will have to redo everything. So and that to there, I'm not having transient case. You see here, I'm having.
Sir, we can drag it to solutions.
Yes, correct, correct, correct. You are perfect. You are nice. So here the only scenario will be just to drag static structural and paste it on this solution portion. Or I can even drag this transient structural also and drop it over here. So I just drag the static structural part, and it will solve me for one. Let's try with both one. Let's just check what happens. So I just insert fixed support. Now it is available because earlier I was in thermal. So in thermal, I will have only thermal loads, thermal boundary conditions. So that's why you that it was not saying earlier. But now I have added static structural. So my fixed support, displacement, force, pressure, everything is visible to me now. Fine. So this fixed support, I will maybe apply somewhere over here where I'm having maybe a pin. Fine. So I apply it over here and simply say solve. So let's see what happens. Okay, I simply right click and say add stress, equivalent stress. I right click insert. Oh, I just right click insert and say deformation. So maybe directional one with the z-axis. So I am double clicking over here. With the double click, this menu will change automatically. Whatever here in drop down. Fine. So I'll say evaluate. Here you can see you are getting results for only one load step, right? So this is nothing but my equivalent stress, and this is nothing but my deformation. So now what I'll do, I'll simply try to drag transient structural over the solution. Let's see how it behaves. But before that, I will delete the one we added from custom, because steady state thermal is not of our interest for time being. Okay. So what I did, in one case, I have added static structural. What static structural will do, it will simply take results from my last load step, maybe this one, and it will calculate results on this load step. But as I know, like I want results for this at this load step, how my temperature behavior, and how are my equivalent stresses, like what equivalent stresses or what deformation I'm getting. For that I need such transient one. So in analysis setting, it is giving me some error kind of thing. This question mark is some error kind of thing, because here in imported loads it has 10 load steps. So you see over here, I'm having 10 number of steps, but here I'm having only one. That's why it is giving me such error. Maybe I shift it to 10. So yes, and now I have got such 10 substeps. Here also, what I need to do then, instead of end time, I'll simply add some rows over here first. I will add rows first. Let's then see what we need to do afterwards. So this is 8, 9, 10. Okay. So starting from first point, so I want it into the first, second, I want it into the second, like that. So source time is nothing but the time, maybe from here. So this is nothing but my source time. So it has started from 1, and it may be from here. So 1 second to 10 second up to here. So what I'm doing over here, maybe if it's allowing me to take it from first, let's see what we can do. So third, fourth load step, and likewise fifth, so six, 7, 8, 9. So only one is here, 6. So now what I did, I have taken all the source times starting from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and I'm using these results in the same load steps. So in the static structural, getting. So here what I did, so maybe let's check this one. So what it is saying, my end time is nothing but 10. Correct. So let's consider it starting from 0 seconds to 10 seconds. So end time is my 10 second. So end time result will be considered in my first step. So wherever I'm having is a first step. So you can see uh, here I'm having only one step, right? So only end results are considered over here. But now in case of transient structural, what I said to my software, let's use like whatever in there in first load step, same thing you use here in my first load step. Whatever available in second load step, you use same thing here in my second load step. Likewise up to 10th load step. So whatever I'm having results in my thermal calculations, like in this transient thermal of 10th load step, you use same results in the 10th load step of my transient structural case. Got it? So have you got this, or shall I repeat it? because I know this is little bit tricky to understand. But have everybody understood this? Yes.
Yes, sir.
Okay. Okay. Great. So what I am doing over here, I am extracting results from my calculated set, which is nothing but transient thermal, and I am using those results in my transient structure, which is nothing but here it has written as analysis time. Fine. So maybe fixed support. I have added the fixed support. Now here auto time stepping is on. Maybe I can make this off too. And here time step, it is mentioned as 0, but you can see over here what is my time step. 1, 2, 3, 4, 5 means difference between this is what, 1 second. That I can mention over here. Time step is nothing but 1 second, and I have to go up to 10 number of steps. So starting from 1, correct? So yes, maybe I can import the loads. Let's see. So you can see these results for time step, maybe for second. Current step number 1, step and time 1 second. No. Let me check why actually it is giving me such a error, but it should not give basically. I should have done this. Or I have one more option. If it is not possible here in transient, I have one option to do it in structure also. Let's check that also. So maybe I just drag and drop over here static structural again. The first, what I'll say, the system, I will again dragged it. Make it over here. You can add the rows. 7, 8, 9, and 10. Fine. So starting with my first, second, third, 5, fine. So 1 to 10. So all the source times and all I have added. So I just say import. Fine. So it has imported for me data from 10 load steps. Maybe you can see it over here in graph also. So let's just make these steps count to 10. So instead of 1, I made them 10. So fixed support, it is applied for 10 load steps, and even this body temperature, You can see here in graph also. So it has, maybe I just want to pin it to somewhere over here. Okay. So you can see this graph. So the imported body temperatures, from where it has imported it, maybe you can just go here and see. So, so that is imported from this transient thermal tab. So from solution of transient thermal, so it has taken the data as an input for this static structural calculations. Fine. So I'll go again over here. So I have added fixed support and I have all the temperature data. So I'll simply right click and say solve. So I am solving this system for now 10 load steps. Let's see how like what results I'm getting. Okay, got it. So just right click and maybe say stress, equivalent stress. Right click, insert and say deformation, maybe the direction deformation. And you see, or maybe we can compare the results. So equivalent stress over here and equivalent stress over here. Exactly similar, because here I am at load step 10, but now what I am doing now, I am shifting it to load step 5 or maybe 6. Let's see. On right click and say evaluate. Can you see the difference? So here I am having equivalent stress in the range of 900, and the earlier one where I was having, so it was at the range of 2000. So that's at the last time interval, and this is somewhere in between. So have you got now? So why we need such transient calculation? So basically, in first portion, so time being, I can say you do not go with such transient calculations or transient structural calculations. You can do same things by using static structural as well. So no need to go for that. But I'll check. But I know it is possible to do that. I'll check and maybe I'll come back to you on that maybe in upcoming sessions. But for time being, you have this, and you can have results maybe a stepwise. So here also a directional deformation. I can check it for the required time. Fine. Do anyone have any question? So I have shown you by importing it. These are my results basically, and I just want to check results at any required time. Okay. So anybody have any question? If not, then we can just check for other problems for today. And the one, I think Shakti, have you done this calculation? Have you done this calculation along with me? Hello, Shakti, am I
Yes, sir.
audible? Okay. Have you done this calculation along with me, or do you stuck somewhere?
No, sir. Just listen it. Just listen it, sir.
Okay, you
After
haven't
this class,
tried.
I will done. I will do, sir.
Okay. Fine,
Yes,
fine.
sir.
No issues. I thought you were trying with me. Fine. So you can try this. For time being, you just leave that transient structural portion. You can try with these two options for time being. Okay. Now I'll simply save this. Let's move on to the other problem. Go to the maybe 7 and number 7. Fine. Let's check what we have in our second problem. Okay, so we have over here the same break disk, and again we have time stepping, and this much temperature we have. Okay, now I just go to the transient case. Just double click on it. Say, just check the material. I have structural steel, that's fine. So I simply, okay, there is one more option in design modeler, but it is valid only for 3D bodies. So it is not valid for 1D elements, or it is not valid for shell elements or maybe surface bodies. So from here directly you can simply say import geometry. So if you right click on geometry, you have two options, like either you can open ANSYS claim in design modeler, or there is one more option, import geometry. So directly you can import it here also, but it is only applicable for 3D bodies. That's why I haven't told you until now, but as you now very much familiar with to this, so I told you the shortcut. So by this way also you can import your body, but the criteria should be, it should be solid. Right. Now I need to check units. Fine, they are in millimeters. So do we have any mesh size? Yes, so 10 millimeters. I simply right click and say generate mesh. Okay, so now I will say insert and add temperature. So I have temperature on the two faces, that to 200 degrees Celsius. So let's select the face one. Just I'm rotating it with my scroll click, like I'm having scroll button, like middle click I'm rotating it. Here I am simply this is right click and drag, so it will zoom my body. So right click and drag, it will zoom my body. Scroll, I'm scrolling it like to and fro, and if I am pressing my scroll button, I can simply rotate this body. So here I can just press control key and select these two faces. Let's say apply. Got it? So now so maybe 9 dot steps. Let's try with like steps over here in this example. So just go on to the temperature. Just I'll drag it over here. Let's enter the temperature values. So at 0 I'm having 0. At 1 I do not have. At 2 I'm having 10. At 3 I'm having 50. Uh, 4 no. At 5 I'm having 130. 7 I'm having 150. 8 I'm having 170, and at 9th I'm having 190. Fine. Now let's just go here, and the one I don't want, so this fourth load step I don't want. I think second also I don't want. Second I want, first I don't want. Okay, first and sixth. So what I will do, I will right click and say deactivate. So you can check here from the graph. So my line it start from this one. So 1 2 3, and from 3 to 4 I do not have anything. That's why I just deactivated this fourth one. From fifth to sixth I do not have anything. Getting my point? So you can do it like this way, or you can simply keep those values as it is. You will not have any difference in your results. Only your solving time will be reduced. So by doing this, my calculation time will be reduced. So that's only the benefit. If you keep those as it is also, it will not affect your results, because you will be extracting results maybe on maybe this fifth load step, so that is on 130. So it will not have any impact if you keep this or maybe deactivate this also. Fine, but time being we will just check this. Let's see what happens. And yes, the second thing is I need to apply the convection. So let's just go over here, go on the box selection, select everything. Now click control button and just remove these two faces and say apply. And the value I should enter is 0.2. So 0.2 value is constant over the time. Fine. So right click and say solve. So now it will solve for my maybe 9 number of load steps. We will have results for all the load steps now. Okay, done. So that's solved for me. Now I will add, just right click, say insert. In thermal, I'll add temperature and simply say evaluate. Okay, so I'm getting the results. Here you can see uh, the disconnected line you can see from here in this green dotted line. So, which means from like maybe 4, I have just deactivated my loads. That's why you are getting such lines. Got it? And it has reduced my solving time for that. And if I just want to maybe now extract results for this load number 6, let's see what I'm having in load number 6. Oh, it's deactivated. So it has automatically selected this load number 5, load step number 5, right? So 6 is deactivated. So even if I click on 6, it has selected for me this 5 one. So I'll go over here and again just check where I'm having my fifth load step for this one. So right click and say retrieve the results. So it has given me results for this 130 degrees Celsius, means fifth load step results. Same thing now, I can check with the heat flux. So I simply say evaluate. So I will have the heat flux results. Got it? So these are nothing but results for my transient. Let's check whether we have, okay, we do not want results for stresses and deformation in this case. So we are done for this. We have completed calculation for this transient case. Let's check maybe for the next problem. So here again the same thing, heat sink we have. Maybe I can simply check whether if I have saved our yesterday's calculation just to have comparison. Maybe yes, I think I have it. So I'm just opening calculations what we did yesterday, just to have one-to-one comparison. So what is happening really in steady state calculation? So now we have solved for brick. So I guess here we have, let's check first which was the problem statement for the brick. Second one. Fine. So I'll open this part, problem number 2. I will drag it to left side just for comparison, and in right side I will have results for the transient thermal case. So here you have on my left side I am having results for steady state thermal case. On my right side I am having results for transient thermal case. Fine. So you can see temperature over here ranging from 0 to 200, and here I'm having temperatures. Maybe I'll simply move it to a little bit this side. So in single load step, I'm having. I'll simply close this. I don't want it. Okay. So here, starting from 22 to 100, and maybe just go and check the temperature results, and here I check my temperature results. So currently they are on the, maybe I will go here and say retry. Here basically I am having a little bit different load. So my last load is of like 190 degrees Celsius. So that's why I'm seeing such difference in these two results. So 190 and 204. So this much. But you can see over here, I only have in results, you cannot see like any graphical results or anything. And here if you just go on temperature, you will have such graph from where you can just right click and say retry, and you can extract those results. Or either you can do same thing from here. You can simply click on this table row, and you can say right click and retry. You can get those results. Fine. So the main difference between these two calculations. Let's just move now to our next problem for today. I will have look first on the problem. So this is nothing but my heat sink. So on this heat sink, I will apply temperature from my bottom face, and I will have some fins just to cool it down. So let's see how I can apply those. So I'll go to the transient thermal. I'll simply double click on it. I'll say problem number 3. Now I'll check the material. So not mentioned means default material I'll consider. And from here I'll simply import my body. So here basically what earlier bodies I imported, they will be shown here. So I want think nothing. I'll simply browse it again and say maybe I'll go back one step back, and here so hit sync. Fine. So I'll double click on model just to enter into the mechanical. Okay, now I have the mechanical window open. Do we have any mesh? Okay, it should be default. So I'll right click on mesh and say generate mesh. Okay, now what I need to have temperature on this bottom face, and all other remaining faces will be like having convection faces. So yes, all remaining phases will have convection, and here actually I need to use stagnant air and vertical plane. So this system I have to use instead of just a constant film coefficient. I do not have any constant value over here, but I want to use this system of stagnant air vertical planes. And as we did yesterday, these models are already available in ANSYS library. Okay, so we will define temperature first. Before that, I'll just check the load steps. So 7 load steps I am having. So into analysis setting and number of load steps, I just mentioned 7. And now I just insert and say temperature on this space. Okay, I'll simply drag it to this side, and yeah, let's just add the temperatures. So starting from 0, 1 it's 15, 2 it's 50, it's 3 it's 75, it's 90, 5 it's 105, 145, it's 200. Fine. So I have defined the temperature. Now I have to define convection. So insert convection. I simply click it over here. I go to box select. I just drag it from left to right, and I again go to my single select. I hit control. I simply click it over here, and yes, so I have selected all the faces except where I am having my temperature. Now, instead of film coefficient, I do not have the value. Just click on this row. That arrow will appear over here. Click on that arrow and say import temperature dependent properties. So here I am having that convection data, basically import convection data, and all the samples I am available. I have it over here. So which sample I need to use? The stagnant air vertical plane. So stagnant air vertical plane. So this one. Right. So you did yesterday. Now I think my temperature is applied. Convection it is also applied, and I have set number of steps to 7. Now I can solve it. So just right click and say solve. So here I want results for my temperature distribution. I want results for my heat flux. So these two results I want. Okay, it is taking time because we have here number of load steps. Okay, around 70-80% portion of calculation is complete. So it might be into the last load steps. So this upper one, it is showing you the overall progress. The bottom one is changing according to my steps. So we are into the last load step. and we are writing results for my last load step. So this is the final step. Yes, I'm done. Now I'll right click and say insert and say thermal temperature. Right click, insert and say heat flux, or maybe I'll say directional one and hit y axis. So right click and say evaluate. Can you see the results? So here we have results for my by default last load step, and here you can see in right. So it has taken multiple steps to solve this. So even you can control this in between sub steps also. So maybe I'll explain you here itself. We will zoom it. So here you can see for time one, I'm having temperature, and it has divided that temperature again, like starting from 0 to 1. So 1 into 10 raised to minus 2, 2 into 10 raised to minus 2 means it has divided my this stepping like from 0 to 1 into 20 sub steps again. So I know this will be hard to digest at first time, but uh, just for your information, you need not to have by heart such things, but this is just for your information that this also you can change. Maybe uh, I'll clear these results first. Let's see. In analysis setting, so what it is saying, I'm having seven steps, and here it is saying auto time stepping, which is program control. So this is program control. That's why it has defined 1 into 10 raised to minus 2 and 1 into 10 raised to minus 3 minimum time stepping and initial time stepping, right? But if I do not want to have it program controlled, I set it to on, right? And instead of 0.01, what I will give, maybe 0.5. Minimum time stepping I will again give 0.5, and minimum time step is 0.5. So what it will do now, so in earlier case, just remember we had like 20 steps in between 0 to 1. So those were that I call it as sub step. So my original seven steps are there, and in between them, now I am defining 0.5 as a sub step time. So my calculation will start from 0. My first point will now come directly to 0.5, and second point will come on 1, third will on 0.5, fourth on 2. So earlier what I was, it was by default it was 0.01. So it was starting from 0, then 0.01, then 0.02. That's why it took a lot of time. So I have defined it by myself. Maybe let's check results now, how we will get it and how faster we get it. So okay, we are into the last load steps, maybe last one or two, I guess one. Done. So writing results for my last sub step. So have you got to know the difference between step and sub step? So here you can find it out. maybe I'll go to, you can see 0.5 to 1. But now you will say me like, why for others they are still more? Because I only defined for one. So I only defined for current substep one. Maybe if I just switch to 2, let's see what is there. For 2, it is program controlled again. Maybe for 3, it is again program controlled. So I only defined it for 1. That's why it has simply switched my 20 load steps to only 2.5 and 1. So you can do it for all others also from here, like from analysis setting. So you can define this time stepping for all other steps also, for 2, 3 to 7. Fine. So I simply retry these results. Let's see. This one I retry. Okay. So we got these results. Let's now check what else we want. I want equivalent stress and total deformation. Okay, fine. So to get equivalent stresses, I will not get those stresses from here, like doing like insert and add. But for that, I need to add static structural portion into this, because it will only deal with my stresses and deformation. So I'll drag it and drop it over the solution. I'll simply double click, so the main mechanical window will get open. Now I have to give a fixed support somewhere. So maybe I'll select this and say insert and say fixed support. Okay. Now in import data, what I'll do, just add some rows. Okay, 5, 6, and 7. So I start from 1. Here 1, 2, 3, 4, 5, 6, 7. So from first step, I want results to be calculated in my first step again over here. So instead of 1, I simply change it to 7. Okay, I say import load by right click and say import. So you can see the temperature profile, and I have applied fixed support. So I think I'm done. I just want to say solve. If I don't apply that fixed support, then my this calculation will not solve, because for static structural you need some support. Otherwise, now if I'm having my thermal stresses in it, and if I do not have any fixed support, then my body will simply move in my space and it will not solve, or my solution will not get converged. That's why I need some fixed support to get my solution solved. Just for my convergence, I need this fixed support. Okay. So as it considered earlier for, so I'm into the last load step. Yes, it is done. Now I just right click and say stress and equivalent stress. Right click and say maybe deformation and total deformation. Let's see how it behaves. Okay, got the equivalent stress. You can check this. So I can get stresses maybe from this load step number 3. So anywhere midway I can get the results. So same thing for the deformation. So maybe in midway somewhere over here, I can get the deformation results. I'll say retry. So these are the results. Okay. So anyone has any doubt? Do anybody have any doubt? So here we have done exactly similar things what we did yesterday, but yesterday we did only for steady state thermal case with only one load step, and today we actually used multiple load steps. Means we used my loading condition, maybe my temperature, with certain amount of steps. So that's I did. So if you have any question, you can ask. Otherwise, I will simply check my next question. Uh, okay, here I'm having uh, analysis for the engine block, and that too. Here I need to calculate equivalent stresses and deformations too. Okay, maybe we will quickly solve this, and maybe at the end, let's see this one. Okay. So what I will do, I will add again transient thermal. I will add the geometry. I'll right click and say import and say engine block. So earlier, yesterday we did it. That's why it was in my library that used models. So I simply took it. On model, I'll right click and say edit, so that my mechanical window will get open. So let's just go to this tab and see. Okay, my mechanical window is open now. So this is my engine block. So again, same thing from inner side. I need to apply these temperatures, and first of all, I'll mesh it. So, a default material is structural steel. I have defined. I simply right click and say temperature, and just say this portion. So want to apply temperature. The analysis setting. Uh, I just want, maybe I'll keep 13.6. Just let's see how it goes. The temperature, so time 0, will have my temperature 0. Let's just check. For time 1, I'm having 45 degrees Celsius. Correct. For this one, I'm having 150. Okay, here I'm having 250. Uh, I'm having 390. Again, we have some times missing. So maybe just a moment. Okay. For second one, I will keep him as 45. For third one, I keep it as 150. For fourth one, I keep the same thing, 150. And for fifth, I keep it as 250. Sixth, I keep it same. Seventh, I want it 390. Eight, again 390. 9, I want 480. 10, 480 again. 550. 12 again, I put same 550, and here I just enter 600. Fine. So you can come to know that I have applied such loads, and wherever, like which steps are not present, maybe like here I do not have second time interval. So there I kept same temperature, same to the time factor 1. And same thing we can do over here, means we can simply just click it over here, and we can simply right click and say deactivate, so that we can easily do it over here. But timing I'll solve it for my full load steps, because yeah, they are not much. So we'll check this, like how I'm getting my results. So this is temperature, and now I have to apply convection. Let's just right click and say convection, and maybe with the box select. Now I just go and select single select. Now I click control button and just simply deselect these faces and say apply. So 242 total faces are selected. So there I need to use again a system of stagnant air, and that to a simplified case. Just now click on this film coefficient, that arrow will pop up. Click on that arrow, then say import temperature dependent data. And here I'm having stagnant air and simplified case. This one, stagnant air, simplified case. Just say okay. Got it. So now I have defined the temperature, even I have defined the convection. So my part is done. I'm just saying solve. So it will take a little time, as we have defined total 13 load steps over here. So let's wait till that run gets completed. So meanwhile, I can also check how many are there still present. Let's check. So there are 10. I think at start we were 15 today. So that's fine. So maybe I will have a look on the next assignment. What is it? Okay, so this is related to maybe contact analysis. Mm-hmm. Good. And we have left with this assignment too. Mm-hmm. Okay, then probably on Monday, I think we will complete this left one, like the assignment number 2, because yeah, when we cover this, then maybe we will move to the uh, next, like contact analysis and all stuffs. So this is one remaining, because here we have 1D elements. So let's just try to complete that first. Okay, so here we have completed this run. I think we are into the last result writing. Yes, it's done. Now what I will do, I will add apply temperature, and I will apply heat flux. So let's see the results. I can find out. Maybe you add one more static structural just to have results for all the load steps. So I'm adding one more. So just double click on this. I will just drag and drop fixed support. Here in analysis setting, I switch to number of load steps 13. Here in input, I need to define like every load step. Or here I have one more option. Maybe I'll tell you. Let's see. Here I'm having 1, 2, 3, 4, 5, 6, 7, 8. Only 8 load steps. So instead of defining 13, what I will do now, I will define only 8 load steps. And here in import, maybe from 0, I will take, so it's not taking basically a 0. So just maybe I will take from 1 to 1, from 3 to 2, from 5 to 3, from 7 to 4, from 9 to 5, and from 11 to 6, and I want one more basically, so I'll make it 9. So I had it already, so it's possible here. I'll just make it back to 7 again. So I don't want this, I delete this. So I imported 9th step into my 5th, then 11th into my 6th, and 13th load step into my 7th one. Fine. So what I did over here, instead of taking 13 load steps, I simply took the required load steps only. So these are only 7, but over here, like I do not have second, I do not have fourth, even I do not have sixth. So what I did, starting from 1, 3, 5, 7, 9, 11, and 13, but these are my continuous 1, 2, 3, 4, 5, 6, 7. Right. So these are results of my thermal calculations, and this I am taking it into my static structural part. Correct. So now I just import it. So this way you can also you can do, or the general way, like you just define 13 load steps and you take those 13 load steps to my 13 load steps in my static structure. So by that way also you can do. So you have both options, but this is a little bit faster because here I am having only 7 load steps instead of 13, but I will be having results on all the mentioned time steps. So see how fast it is. So it got solved very quickly. So I just go and check equivalent stress and maybe deformation, total deformation. So got it. So these are my stresses and deformation into it. Fine. So I think yes, today we have covered a lot. But I just want to ask, do we have any question? So on Monday, probably we will be completing the left session. I think session number 2. There actually it is important because we will solve multiple questions related to BA. So we will solve some real world calculations, and I think it is important for you. Maybe some of you might be participating in BA, so there it is necessary to do such calculations and prepare a report, right? So maybe our Monday session will be important, and yeah. So do we have any questions? So we are 7, including myself. So I think if we have any question, I can take it in next 2 to 3 minutes, and if not, then maybe we can close for today. Mm, okay, I guess then we do not have any question. So yeah, let's just close our session for today. And now let's meet on Monday again, so with the new calculations. Yeah, I wish you a nice day ahead, and bye bye.
Thank you, sir.
Yeah, welcome. You're welcome.